Okay, cool. So this is a slide deck that I originally presented at the Canonical COP in London a few weeks ago to the larger QA organization across Canonical. So this was to kind of get some cross-team sharing and collaboration. We wanted to get some other teams using SST, so I put together a quick slide deck that I'm going to show you guys. All right, so SST or Selenium Simple Test is the name of our framework. The basic architecture of it is we build on top of Selenium WebDriver. So I know you guys, or at least Mars, has been somewhat familiar with Selenium 1. So let me just do a brief intro to what Selenium is and was and kind of where they're going with the project. So Selenium was originally this JavaScript-driven browser test framework where you could sort of put together these HTML tables of sort of some basic web commands, and you could verify certain elements and sort of run this very primitive test structure against your web application. And what Selenium 2 is they really pulled away from making it a test framework, and what they've really concentrated on is creating a really stable, really good cross-platform, cross-browser library for driving browsers. So that's really what Selenium does. And the new API for Selenium is called WebDriver. So the WebDriver API is, they have client bindings for multiple languages. So we've been using the Python ones, and that's been great. They also produce these clients for various other languages. They have switches to choose which browser driver you're going to run. And they've kind of pulled back and made it this lower level component, which forced us into the situation of we need a higher level framework to build on top of that, and that's kind of where SST comes in. So SST is sort of a mashup of Python's unit test with using Selenium WebDriver to drive these set of tests. We provide a simple set of actions, which are these Python functions that kind of allow you to abstract some of the guts of the API away and just have this sort of clean interface to work with, where you get a test runner, test case loader. We have some appearance to parameterize data, and then a nice reporting output, which either comes out in its own HTML report, or it can produce a JUnit XML report to integrate into other systems. So that's kind of Selenium WebDriver real quick. Here's just a quick example of actually using WebDriver straight from Python. So basically all you need to do is install this Selenium package, a pip install from Python package index, and then you can write this code to interact with your browser and the underlying web elements of your application.
Now I'm assuming you have to have the browser installed.
Mostly, yes. There is a so there's various drivers, and they all run by launching a physical browser. There is an HTML unit one that runs without launching an actual browser. It's just sort of an abstracted framework on top of it. I haven't used that much and haven't had good luck with it. Another neat feature that I'll be getting to, though, is the ability to run these in a headless mode. So even though you still do need the actual browser there installed, and you need to run it for every test case, it won't be popping up in front of your face. You can run it on a VPS somewhere in the cloud and just let it kind of run and do its thing. So if we look at what SST is built on, here are the various libraries: Selenium, Unit Test 2, JUnit XML, PyVirtual Display, which was for the headless mode I just mentioned, and then it has a Django web application actually built inside it that we just use for internal testing of the framework. So when you run the when you run the framework in test mode, it's sort of the reverse of a normal application. We'll launch our own web application and do all of our testing and verification internally right there. So we provide a set of actions. This is basically the public API that we're presenting. So this is a good link to have, that actions reference. So this is basically all of your tests are going to be constructed of pieces right out of this API doc. So this is what allows you to drive the browser to navigate around websites and interact with elements and objects on the page and assert various conditions or behaviors were met. So you definitely want to take a look at that API doc. So if we were to look at composing these actions into an actual test, so all you're going to do is import the actions. I showed two examples, kind of a good Python practice of importing actions as a namespace and then kind of just mashing your global namespace and importing the whole API. But again, these just map to underlying Python functions. So a very simple test could be go to a URL and just verify that the title contains something. And so this is all you need for a SST test. There's no setup and teardown. That's taken care of for you by the test runner itself. Let me just move forward in this. Yeah, so the basic idea is you have this set of directories, your test directories, and you create a bunch of these Python script files inside them. And you can nest the directories in whatever style you want just to kind of make logical organization easier. And what SST is going to do is it's going to walk through your directory tree, it's going to pull in all those tests, and it's going to run those against your application or system under test, and it's going to handle a lot of the kind of boilerplate stuff of like launching a new browser every time, tearing down your browser between test cases. So on this screen, I'm just showing once you would have that simple test case, you just call the SST run command and pass it a test case name, or you can pass it a directory and it'll walk the directory and run all test cases under it. So it ships with a bunch of examples in self-test. So if you guys want to dive right in, at the beginning of the slide deck, and I'll pop it up at the end as kind of just a quick start guide, and you can just run through that and then dive into these examples and self-test. It's probably an easy way to approach it. So if you were to do this st-run and then give it the examples directory, it will run 3 examples that are packaged with SST. And if you give it the --test argument, it'll run the internal test suite. And you can look in there and kind of see how we're interacting with objects, and maybe that'll give you some ideas for how to go about setting up your tests. So here's what you get. You can get this integrated report directly out of it, or you can have it spit out XML, which is it uses the JUnit format, which is really nice because it makes it compatible kind of right out the box with our Jenkins continuous integration setup. So you can kick off these SST tests as a Jenkins job, and because we're leveraging the JUnit XML, we kind of automatically get the nice statistics reports. We get performance trending and kind of a lot of the stuff that's built into Jenkins automatically, which is really nice.
Does that mean that Jenkins will run these tests too, or do you have to run them and then upload the XML file?
No, it's all initiated by Jenkins. So like I could show you I have a test VPS which has Jenkins installed, and I have a suite of tests that point against like our staging environment, and I can run from there. And it's all just one step. It's just one click of a button and everything runs. The results are pushed back to Jenkins and consumed, and yeah, there's no separate step.
Nice. And so your Jenkins server, even though it's a VPS and it's headless, you have Firefox installed on that server itself?
Yep, absolutely. So it's Ubuntu server, so it had no desktop environment initially, and I just installed Firefox. That pulled in a lot of the kind of minimal GNOME dependencies and stuff like that, and yeah, and it just runs headless Firefox in the cloud. It's really nice. So kind of that's it for the information. I can run through some examples if you want. I don't know how the screen sharing will work if I'm launching multiple windows here, but I could show you that. I could show you Jenkins. I could answer any questions, or I can just let you guys kind of dive in and ping me with questions later.
Well, since we're recording this for others, how about some demos? But first of all, would you maybe just go to the API doc and just kind of walk through some of those? I mean, most of them are pretty self-explanatory, but just maybe point out things that you think are particularly interesting.
Sure. Okay, and before I even go through the API doc, let me show you the documentation in general. So we use Sphinx to build the documentation. So we have a simple restructured text file, and we also have pretty nice doc strings in our API itself in the Python code, and we're auto-generating this documentation based on the doc string. So this kind of walks you through a little bit of how to install it, a little bit of background, kind of a quick start guide. So you can, right now you have to pull from the Launchpad project directly. We're going to be releasing it in an easier consumable way soon. But once you have that branch, you can either run directly off the dev branch, or you can, there's a setup.py file, so you can pip install it, and you can install it locally, and soon we should have it on Python package index, so you can just pip install it remotely. Okay, so at the end of this is just a link to API docs. Let me just walk through that. Okay, so what the API does is it takes a lot of the underlying WebDriver functionality and it exposes it a little bit simpler and more of a straightforward kind of function action based pattern than basically what we were trying to shoot for was to get this mix of where you can still use Python and still have all the power of the scripting language. We didn't want like a keyword driven framework or something that mapped this specific language we invented to some higher level actions. We wanted it straight Python, but we also wanted to produce a very simple API, so maybe someone who's not too experienced with Python but is into testing and QA could probably get their feet wet and get involved in writing tests. So that's kind of why we settled on this level of abstraction. So what this does is it's going to map some of the basic WebDriver API commands, which are just trivial wrappers, and then some of them are definitely non-trivial functions that do a lot of the kind of nastier stuff under the hood for you, so you can just call a simple function and have that work. So there's basic stuff like, if we just walk through the first couple here, like clicking on a button, setting a checkbox, clicking on various elements. The most important thing and sort of the basis of all your tests is going to be this get element and get elements. So what it is there's this concept of a web element, and that's basically any object that you can pull off of your screen. And what the get elements so the get elements would give you a list of elements. Get element would return you a single element, or throw an exception if it can't uniquely identify. So you can pass in various parameters to identify these elements, such as if they have an HTML tag, a CSS class, if they have a specific ID, if there's a specific text value. You can pass kind of any combination of these in to uniquely identify an object. So if an object has a unique ID, like, you're great, you can just kind of drill right down to it with one specifier. Maybe your web page is not constructed with unique IDs, then you have to kind of use a combination of tags and text and whatever else to identify these elements. But basically you want to get hold of these elements, and then you want to assert various conditions, kind of just like a unit test. So most of the actions we have take this element as a parameter, so you can pass, and usually you can pass in a unique ID or the element name, and it'll do a get element under the hood. But most of our actions will take an element, so it's always that first step of identifying the object on the page, and then you want to verify, validate, assert something about that. So whether you're looking, does a title contain something, does a specific text field match something you're expecting, does a value in a table match some expected value after you do some action. So whatever your test is made up of, kind of, they can be mapped to these higher level actions, or at least that's the idea.
I don't see anything in here where you're telling it what browser to use. Does it just automatically select one?
So it defaults to Firefox. That's the default browser. It's actually a command line switch. If I can find, let me go back here. So there's a command line switch. You pass the -B at the command line, and you give it a these map to WebDriver, the client binding names. So the one for Firefox driver is just would. So if you put in -B Firefox, you get Firefox driver. If you put in -B Chrome, you get Chrome driver. So you can kind of route these through any browser you want. I've only really tested it on just under Ubuntu on Firefox and Chrome, but we have had one user on Windows with IE. There's nothing that should preclude anyone from running there, and we should be able to support any browser that the WebDriver bindings support.
So let's say that we were going to make a simple example. For example, let's say we've created a web app, a Django app, and we've got these tests right here in the app. And what it does is when you open the app, it shows you a list of people, and then when you click on the person, it takes you to a form where you can edit the details about that person. And then you can save the button, and it should save the changes. You know, if you were going to write tests for that, how would you do it? What would your test look like?
So if I were just looking at something like that, what I'd want to do is figure out a basic scenario that you could sort of walk through manually, and then just create actions to follow that process. You'd do where you select your person and submit the form, and that's usually done by, so you're going to interact with these objects on the page, and you're going to set their values, and then you're going to click on whatever button, the submit or whatever it is that is on the page, and that'll kind of move you to the next page, the form. And so what you want to do when you move to that form is you want to do some validation there, assert various elements are what you're expecting. Perhaps there's details. You want to check that the person's name matches the expected value of what you passed in, so you know you're on the correct details page. You want to go ahead and verify some of the underlying properties of that page depending on what you're actually testing, and yeah, basically just walk through the workflow, kind of asserting everything from a very high level, so you're kind of working at the same level that a user is working at.
And so you would program it to maybe try putting an invalid email address and make sure the JavaScript, validation warned me that doesn't work, and
yep, and you probably want to break this down into like several tasks. So you wouldn't want to just create this one monster test that walks through everything. So you might want to create something like, let's create a little test suite that just or a little test case that just walks through the JavaScript validation. Maybe it just tries putting in a bunch of different examples and seeing if it can submit a form, seeing if the JavaScript allows them to or disallows them to, or whatever. Then you could create another test where you kind of have this successful happy path flow where you're walking a little further into the app, and you kind of just keep building tests on top of that until you have this like nice workflow that kind of goes through the feature you're working on and really tests everything nicely from a high level.
You mentioned that you tested against staging instances of applications, and so your Jenkins instance is running the tests, and the application is actually already deployed to a staging instance. Would it be unusual for a test script to preload a local instance of the application with data and then have it run a test and then confirm that the data was entered correctly by using the backend directly, or would that pretty much would you just test through the browser?
Yeah, this is very much geared towards the browser. I mean, you could hook in and do any kind of. See, the real beauty of SST is everything at the end of the day is just Python. So like realistically, if you wanted to, you could create a test script that did whatever you wanted, and you could have that. And you can actually mark stuff. I said there's no setup and teardown, but there's this concept we're putting in of like kind of local setup teardown stuff, so you can have specific steps. And if you wanted to create something that actually did some sort of back-end validations between your tests or whatever, you kind of have that infrastructure or ready to go right there for you. And so one other neat thing is, so all these tests run, or the way I've shown it is everything runs locally. So where you have your SST framework installed, that's where your test scripts are going to live, and it's going to launch a browser locally on that machine. Now, the neat thing about the way that Selenium WebDriver is architected is it has this kind of distributed model. So there's actually an intermediate server that you can put in between your browser and the client-side bindings that allows you to control browsers remotely on other machines as long as they have this server running.
So for example, you can have a machine that runs your Internet Explorer tests, and your Jenkins server could talk to it and run the test through IE without having to install it on the actual machine that has IE on it.
Yeah, exactly. And then taking this a step further, there's some new businesses out there that are building these. There's one called Sauce Labs. What they've done is they've built a Selenium-enabled, basically big grid. So you can choose if you want to do cross-browser, cross-platform validation. You can pick basically any browser OS combo you can think of, and you can just, through their remote API, which SST supports, so you can do this right out of the box right now. You can run stuff on their grid, do your full suite of cross-platform, cross-browser verification or validation, whatever. And yeah, it's kind of just built in for you. It's pretty sweet.
So I think we're about done, but I was wondering, can you just give us a few tips on how to make sure that our tests are good, and maybe some things to avoid that are just going to cause pain?
Try and stick to the API as much as possible. So one thing it allows, the framework allows you to do is you can get a hold of, you can import the underlying WebDriver libraries, and you can sort of subvert the framework and end up writing your own test directly to the WebDriver elements, and that's kind of a bad road to go down. You want to stick with the API, use all the actions we provide, and if something's missing that you're not able to do because the API doesn't support it, you'd want to like contact me or Michael Ford or someone and have us try and get that feature in there rather than working around it yourself, so we don't have these kind of brittle tests that are, we want everything to just follow our API and kind of style of doing things.
Okay. Corey, thanks a lot for doing the presentation. Mike and I are eager to get started using this stuff right away, and we're sharing this with the company, so I'm looking forward to a lot more people using this test. So thanks a lot for doing that. And then, so you are available to answer questions if people need to. That's CoreyGoldberg or at Canonical.com is your email address. So I guess we'll call it a wrap. Thanks a lot, Corey. I appreciate you doing that for us.
Yeah, real quick, there's also a hash SST channel on Canonical IRC. Feel free to drop by anytime, and that's where we can dig into details or if you have examples or whatever.
Cool, great. We'll do that.